Okay. Is this open? Yeah, you can hear me? Great. Okay, so tonight we are going to talk about 30 billion devices and whether we are going to be ready to get to this number by 2020, or what changes should we do in order to get there. So before I start, I need to have some contribution from you. I want you to think 10 years ago, 15 years ago maybe. How did you think the world would look like today? Did you think robots will take over the world? Did you think you will escape your boring jobs and they will do it for you? Do you believe in science fiction movies? And do you think that this will come reality? Well, 50 years ago, there was a science fiction writer, which I enjoy, and his name is Isaac Asimov, that used to say that nowadays robots will neither be common, neither be very, very good, but they will be in existence with us. And I think for 50 years ago, that's a pretty accurate saying, right? He also used to say that gadgetry will continue to evolve on our lives, so it will be more devices per people. And this is connected to our presentation today. Last but not least, he used to say the widely spread disease would be that of boredom. But is that really true if we think about technology and how fast it's evolving? Well, let's take a look. Tonight, you will hear about future technology through Vodafone's eyes, and also infrastructure. What do we need to change in the way we scale now our data centers in order to get to 30 billion devices? Let's take a look how far we've got and where we were at the beginning. Let's see about trends. First of all, beginning? Not so. IoT began in 2009, but in 2014, there were already 1.2 billion devices connected to the internet. Next, 2 years later, just think about 2016. Nowadays, we have 10 billion devices connected to the internet. Think about what this means. We are 7 billion in the world, and yet 10 billion devices are connected. Think that not every one of us has internet access. There are countries where people don't have such access. So a media of 1.84 devices for the entire population, it's having devices connected to the internet. So I think that's a huge evolvement. If we're going to think 2 years from now, 2018, 65% of data centers' information will be private. Nowadays, 80% is what we have information to be private in the data centers. Well, this means two things. The first thing is that information is going to grow extremely. And the second one is that this information will be public. 2020. This is our target. I want to take a look first of what made this change possible. Let's take a look at a few factors that made possible this jump in technology, and mostly IoT. First of all, I'm going to refer to sensors and actuators. Technology has evolved so fast that we now are capable of manufacturing small sensors that we can wear on, we can adapt and adjust, take them with us no matter where we go. And we have actuators, which are actually taking action on some of our specification. But will that be possible without processors and memory? Just think about it. If you have a sensor and an actuator adapted to your skin, let's say, this is of no use if you do not have a processor that has the capability to use that data and send it forward, process it. Nevertheless, it's no use having a device if you cannot send the data. So wireless communication had been enabling this IoT movement and made possible transmitting the data from one machine to another. Nevertheless, as I was saying before, Yeah, 10 billion devices connected to the internet, but we are not all of us technical people. This means that not all of us are programming and used to this kind of stuff. So user interface and user experience were a big approach and challenge for the technology today so that anyone can use applications. Could this lead to 30 billion connected devices in 2020? Now, there are two studies. Gartner is saying 25 billion devices will be connected to the internet by 2020. On the other hand, Cisco is thinking 50 billion devices will be connected. Let's take 30 and see what should we change in the way we work today and how we understand technology nowadays in order to have this number by 2020. First of all, we need to take a look at machine-to-machine projects. These are a huge part of IoT. What does M2M project mean? This means that we have some assets that connect to the internet, to wireless communication, and they are able to talk to peer and to interact between themselves. Now, Vodafone has a few ways on working on these technologies. First of all, we have the automotive pillar. I don't know if any of you in public knows, Vodafone in 2014 has acquired Cobra, which is a manufacturer for electric pieces of cars. Yeah, so they used to work with Audi, BMW, with Lamborghini, and not only, they used to make car sensors for Toyota and Renault. So Vodafone is really interested in investing in this technology. Just think about those movies where you used to see, that the cars are driving you to the office and you are not driving the car anymore. Second, healthcare. This is a quite big approach and a big pillar. Just think about it, that you are a cardiac person and you have problems with the heart, yeah? This means that you have to have your blood pressure monitored all the time. Yeah, this is not really possible in the traditional way. You do not have the tools to have your blood pressure measured every time. But with IoT, we have that sensors that we are talking about earlier that can continuously monitor your heart and blood pressure. So this is very important. This information could be sent to your doctor, to your family, could alert you in time to make a change in the way you are doing things. So it's everything in real time and on the movement. Third, wearable tech. Whether we are referring to smartwatches, sports bracelets, wearable intelligent clothes, these are all going to be part of our lives. So this is the third main pillar that we are investing in. And I think this is one of the most approachable nowadays also. Yeah? Smart household devices. This is very popular among YouTube users, that you see that movie, when you wake up, the alarm clock wakes you up, and the alarm clock actually knows what time to wake you up, because it's checking the traffic, because he knows how much time it's going to take you to have breakfast before you leave to the office. So this means that your coffee machine will know when to do your coffee, and you will wake up, the coffee is going to be hot, and your bread toast is toasted already. Next, you come down to the car, and the car already knows traffic information and what route to choose to get you to the office in the most speedy way. Banking, finance, and insurance. This is an everyday living issue, so I think banking, finance, and insurance companies will have to adapt to the new technologies. It's, of course, a challenge for all of us, but once we move forward with technology, everything in our lifestyle must change. Now that we've taken a look at M2M projects, let's see about infrastructure reliability. First of all, we are going to refer to data centers. Now, I want to tell you, nowadays, right now, we have 1 million servers around the world. This is not really much, it's not less. But the problem with data centers is only that we use 20% of our CPU capabilities. So So we are not using the entire capabilities that we are having. Best of the best, Google uses 65% of their capabilities. What we need to change in order to get to 30 billion devices is shifting from centralized data centers to stratified ones. This means there will not exist any longer big data centers across the world, but smaller data centers located in pieces of the world. Because if you think you have information, most of the information can be location related. You don't need to send it to a data center which is across the half world across. You still need to have a data center close to you so you can send and receive data very quick. Yeah? The second point, extended bandwidth between the data centers. I know I said that we will have many data centers. Some of them will be smaller, some of them will be big. But among them, it will still need to exist connectivity. And this connectivity related to the big incoming data will need an extended bandwidth. So we will no longer be able to send the data at the speed we have today, but we will have to increase it in order to have real-time information. Distributed data center management. Once you have many data centers across the world, you need management tools. You need to know what to do with that information. So we need to find a way to manage that data and see how data will come across data centers. Fourth, incoming traffic. Because the many sensors, Gartner is saying that 20 billion of the devices in 2020 are going to be toasters, household devices, and so on and so forth. So only 10 billion will be PCs, tablets, smart devices, computers, and so on and so forth. This means incoming traffic is going to come from sensors. What does it mean? Is that more data is going to enter in the data centers. This means extended bandwidth, as I was saying, but also the capability to manage this traffic. And one of the issues is going to be the backup. Now, we already have this challenge of what data are we backing up and what data aren't we backing up, because it's taking time and it's taking storage. And this will be a great challenge for the data centers managers, because they will need to find a way to automate the system of choosing relevant data to non-relevant data. Next, we are going to talk a bit about devices. And devices are very important. I found a few characteristics that all devices connected to IoT and that are representing IoT itself are having in common. First of all, low energy connected devices. If you have a smartwatch, you don't want to charge it every day. You want to charge it once a week or maybe once a month. So this means they will have to be prepared not to consume so much energy. This means that they will only consume energy when data is sent and data is received. Second, low bandwidth networks to endpoint devices. What does this mean? This means that if I have a house, I don't need my toaster, my fridge, or my air conditioner to send information to the data centers. Why would it do that? It will take a lot of time. I can connect these devices and manage them with my smartphone. I don't need to send the data to the data centers. My smartphone can do that later if I consider that. So we don't need extended bandwidth between the endpoint devices because they can communicate really easy through Bluetooth, through wireless in our homes, and so on and so forth. Security, authentication, and end-device management. End-device management, it's exactly what I've told you about. So we have our smartphone or our tablet, which we can use to have the management of our own devices. Now, security and authentication will be for sure not made in the data centers. You could authenticate and securize these devices through your phone. Yeah? You will have like a master smart device, let's say. Next, I will introduce my colleague Cleo, which is having a case study on healthcare, and I will let him explain more. Thank you.
Good morning. Sorry. Good evening, everyone. So I'm here to talk about how this technology can improve our lives. So in the case study, I would say that my daughter has type 1 diabetes, and we will talk about a continuous glucose monitoring system. So when you have type 1 diabetes, you have to keep your blood sugar, let's say ideally at 100 mark, 100 milligrams per deciliter. But this is almost impossible, so the limits are, let's say, like from 80 to 180. And this in the past was measured with so it's measured now also with the glucometer devices that so you take a drop of blood and you put it in a test strips, and the glucometer device is showing you the current blood sugar level. So when you do this during the day, you do it before meals, because when the diabetes control, let's say, it's done through so the blood sugar is rising when you are eating carbohydrates, and it's lowering when you are injecting insulin. So the diabetes control is done through those two options. When you measure through a classic glucometer device the blood sugar, you have you are usually doing that before meals or if you are feeling unwell. And you will take some blood sugar levels at different times of the day. You'll have, let's say, like in this graph, some of the values. And you will, your mind will, let's say, optimistically assume that this was the progress of the values of the blood sugar during this particular day in this example. But when you have a continuous glucose metering system, you will see this system takes the blood sugar level every 5 minutes. And you will see that the reality is different from what we assumed before. And you didn't stay between your limits. And then if your diabetes control is not so well, you will start to have problems. When you have high blood sugar level, it's called like hyperglycemia. And when you have over much time the blood sugar level too high, you will develop diabetes complications. And when you have a low blood sugar level, you will have that's the dangerous situation, because it's hypoglycemia, and when you have under 50, it's possible to get in the hypoglycemic coma, or even die if that drops even lower. So this is my daughter. The continuous glucose metering system, it's composed of a sensor, under skin sensor that you can see on her arm there, and also a transmitter that transmits proprietary data over some kind of Wi-Fi through proprietary device that's it's a receiver, and can show you the blood sugar level during some time period. To this, we added a bridge that takes the proprietary Wi-Fi data and transmits it over Bluetooth to a phone, a smartphone, that have an Android application and sends the, let's say, uploads an uploader application on Android, and it puts the data into the cloud, into the Night Scout application. That is, this is the uploader application on the phone. And the Night Scout application, it's a JavaScript web application. It's open source, community constructed, let's say, with crowdsourced, let's say. And after you have the data there, you can access it from with any way you can, let's say. You can see it on the phone, on the applications, over the application stores. Also with the web browser on any device. And more than that, it helped us a lot. You can have a smartwatch watch face application that shows you the blood sugar level in that moment, and also it alerts you by vibrating when the blood sugar gets out of the limit you set up. And this is making a difference in our life, because during the night you can wake up and help our child, and also when she's at school, we can see what is the blood sugar level, and can act on this information. So that's all from my side. Thank you. And if you have any questions, we are here to answer.
Thank you.